So today's presentation topic is first law of thermodynamics. What is thermodynamics? Thermo means heat, dynamics means motion. So first law of thermodynamics is that. So law of conservation means energy neither been created nor destroyed. It's always transformed. So now move to the next slide. Here the topic to be covered is first law of thermodynamics and some special form of first law of thermodynamics and enthalpy of a system. So these topics will cover the incoming slide. Now come to the next slide. So thermodynamics law. So first law of thermodynamics is that the total energy of an isolated system remain constant through it may change from one form to another form. So when a system is changed from A to B state B, it undergoes a change in the internal energy, that is delta E A to EB. Thus we can write delta E is equal to EB minus EA. Here they are showing that the two positions are there, original position and final position. So this energy change is brought about by the evaluation or absorption of heat or by work being done by the system. Because of the total energy of the system must remain constant. So we can write the mathematical statement of the first law is that delta E is equal to Q minus W, where small q is equal to the amount of heat supplied to the system and W is the work done by the system. So first law may also be stated that the net energy change of a closed system is equal to the heat transferred to the system minus the work done by the system. So overall first law is that the energy neither been created nor destroyed, it always transforms. In this diagram showing here the original position of the piston and final position of the piston. So showing the in heat the work done is equal to W. So now move to the next slide. Here showing the other definition of first law of thermodynamics. So whenever energy of a particular type disappears, equivalent amount of another types must be produced. So another form is the total energy of a system and surrounding remain constant or conserved. So another types of definition is that so it is impossible to construct a perpetual motion machine that can produce work without spending energy on it. So these are the different types of definition of first law of thermodynamics. So first one is whenever energy of a particular type disappear, equivalent amount of another types of must be produced. So this is another types of definition of first law of thermodynamics. Now come to the next slide. Some special form of first law of thermodynamics is that. So here showing the some special form of first law of thermodynamics. So mathematical statement of first law of thermodynamics is delta E is equal to Q minus W. So in first case, for a cyclic process involving isothermal expansion of an ideal gas, so delta E is equal to 0. So overall this equation is now converted to E is equal to Q, means Q is equal to work done. So in second case, for an isochoric process, no change. Isochoric process means no change in volume. So there is no work of expansion, that is W is equal to 0. So here delta E is equal to QV. So this is another case is a third case for an adiabatic process. There is no change in heat gain or loss, that is Q is equal to 0, and delta E is equal to minus W. In another word, the decrease in internal energy is exactly equal to the work done on the system by surrounding. So another case is that for an isobaric process means there is no change in pressure, that is P remains constant, and hence delta E is equal to Q minus W. So delta is equal to Q minus P delta V. So P is the pressure, delta V is a change in volume. So this is a different some special form of first law of thermodynamics. In first case, the cyclic process involves the isothermal expansion of ideal gas. Isothermal says the uh, delta E means temperature is not changed there, so delta is equal to 0. So Q is equal to W means work done. So another case is isochoric process means there no change in volume means the volumes remain constant. So there is no work of expansion, that is W is equal to 0 and delta E is equal to QV. So there is no change in volume. Another case is an adiabatic process. There is no change in heat gain or loss. That is Q is equal to 0. Hence the equation is now changed. Delta E is equal to minus W. Another case is a isobaric process where there is no change in pressure means pressure remain constant. So equation is now changed, is equal to delta E is equal to Q minus P del V. So now move to the next slide. Here they're showing the solve problem of uh, some equation. Problems are showing here. So find out the delta E where the given Q and W if 2 mole of hydrogen at 3 atmospheric pressure expand isothermally at 50 degrees centigrade and reversibly to a pressure of 1 atmosphere. So the solution of this question is that since the operation is isothermal and the gas is ideal, so del E is equal to W. So first law of thermodynamics is that delta E is equal to Q minus W. So here the Q minus W is equal to 0. So when delta E is equal to 0 and Q is equal to W, for the reversible process W is equal to minus nRT log n P 1 upon P2. So putting the value of this uh, uh, R and different N. So N is equal to 2, R's value is 1.987 and P is pressure. So putting this value we got the minus 1410 calories. So since W is equal to Q is equal to W, so Q is equal to minus 1410 calories. So this types of problem will ask in examination. Now move to the next slide. Another solve example are showing here. 1 gram of water at 373 Kelvin is converted into steam at the same temperature. The volume of water become 1671 ml on boiling. So calculate the change in internal energy of the system if the heat of vaporization is 514 calorie per gram. So the solution is showing here as a vaporization take place against a constant pressure of 1 atmosphere, work done of an irreversible process. W is equal to P V2 minus V1. So W is equal to minus nRT. So putting the value we got 41 calorie per grams. Now Q is equal to 540 calorie. So the equation is, since the putting this value delta E is equal to Q minus W is the first law. So 540 minus 41 is equal to 499 calorie are showing here. So these types of problem are solve student to getting this uh, help for the understanding of problem. Here showing the enthalpy of a system. So therefore the total heat content of a system at constant pressure is equivalent to the internal energy E plus to the PV energy. This is called the enthalpy of the system and is represented by the symbol H. So thus enthalpy is defined by this equation. H is equal to E plus PW. So the enthalpy is a property of a thermodynamic system defined as the sum of the system internal energy and the product of its pressure and volume. So it is a convenient state function preferred in many measurement in chemical, biological and physical system of a constant pressure. So this showing the equation is enthalpy of a system. So here showing change in enthalpy. So change in enthalpy is showing here that if delta H be the difference of enthalpy of a system is the final state H2 and the initial state H1. So delta H is equal to H2 minus H1. By substituting the value of H2 and H1 as equation 1 and 2, we get the value is delta H is equal to E2 plus P2 V2 minus E1 plus V1 V1. So get this value delta E plus del P V. So if P is a constant while the gas is expanding, we can write delta E is equal to delta H is equal to delta E plus P delta V. So delta H is equal to delta E plus W means work. So according to the first law, the delta is equal to Q minus W, where Q is the heat transfer. From equation third and fourth, delta H is equal to Q when change in the state at constant pressure. This relation is usually write as delta H is equal to QP. So where subscript P means constant pressure and where thus delta H can be measured by the measuring of heat of a process at constant pressure. So change in enthalpy change is the name given to the amount of heat involved or absorbed in a reaction carried out at constant pressure. It is given by the symbol delta H as it reads delta H. So the term enthalpy change only apply to a reaction done at constant pressure. So here showing the change in enthalpy. Here showing the unit and sign conversion of enthalpy. Since delta H is equal to H2 minus H1, so delta H is positive if H2 is greater than H1 and the process or reaction will be endothermic. Endothermic means requirement of heat. So delta H is negative if H1 is greater than H2 and the reaction will be exothermic. So in case of chemical reaction carried in laboratory in an open vessel, delta H is equal to H product minus H reactant is equal to QP. Here P subscript is showing the constant pressure. So the unit of delta H are kilocalorie or kilojoule. So in the symbol of delta H equal the sum of internal energy E and the product of the pressure P and volume V is of the system H is equal to E plus PV according to the law of conservation. So here the showing the sign conversion of enthalpy. Here enthalpy of a system. So the calorific value of many gaseous fuel are determined in constant volume calorimeters. Thus, these values are therefore given by the expression QV is equal to del E, where Q subscript V means constant pressure. When any fuel is burned in the open atmosphere, the additional energy of expansion, positive, negative, against the atmosphere is also involved. So the value of Q thus actually raised, that is QP is equal to delta H, may be the different form of equation. So delta H is equal to delta E plus P delta V. If the gases are involved in a reaction, they account for most of the volume change, as the volume of solids and liquids are negligible, small in comparison. We have n 1 mole of gases, therefore the reaction and n2 mole of gases after it. Assuming ideal gas behavior, we have PV2 is equal to N2 RT. So PV1 is equal to N1 RT. Putting this value, we got that del P del V is equal to delta N RT. So substituting this value, equation 1, we have delta H is equal to delta E plus delta N RT. So the enthalpy is a process of a thermodynamic system defined as the sum of the internal energy and the product of its pressure and volume. So it is a convenient state function preferred in many measurements in chemical reaction and biological and physical system. So these are the enthalpy of a system. Here showing the solve problem or example. For the reaction, H2F2 gas is converted to hydrogen and F2 gas. So delta E is equal to minus 14.2 kilocalorie per mole at 25 degrees centigrade. So calculate delta H for the reaction. So after putting the equation, delta H is equal to delta E plus del N RT. So the del N means number of moles is equal to N2 minus N1. So N2 is showing here 1 plus 1 is equal to 2. So N1 is 1. So N2 minus N1 is equal to 2 minus 1 is equal to 1. So putting this value, delta H is equal to delta E plus 1 into 1.987 into 298 means 25 degree centigrade is converted to Kelvin divided by 1000. So putting this value, we got that minus 13.6 kilocalorie per mole. So this types of problem will ask in examination. So the summary of this presentation is that first law of thermodynamics and some special form of first law of thermodynamics and enthalpy of a system. So first we discuss first law of thermodynamics in energy conservation, and some special form of first law is adiabatic process. Uh, an adiabatic process is one in which there is no heat transfer into or out of the system. It occurs very rapidly, or the system is well insulated, that no transfer of heat or energy occur between the system and its environment. So therefore the special form is del Q is equal to 0. So del Q is a minus dW. So another process is a isochoric process and cyclic process, and uh, uh, so isochoric process where the volume remains same, and cyclic process are showing here. So another topic is enthalpy of a system. Delta H is equal to delta E plus P del V. So E is equal to internal energy plus PV means pressure and change in volume. So this topic is showing you the first law of thermodynamics, some special form of first law and enthalpy of a system. So move to the next slide. Uh, uh, References and textbooks. So source of references. The material is presented in this lecture has been taken from various books and internet sources. This instruction material is for the instructional purpose only, and these references will use for the making of this presentation. So thank you for watching that this presentation.